cryptosporidium and giardia. What it really means is that you have to remove 99.99% of the CNG in the raw water. So if you look at the two key parameters in Dongjiang water, we're talking about ammonia and manganese. In our water standard, the acceptable limit is 0.05 parts per million or milligram per liter. Okay. At the worst time, the historical high, for ammonia, we're getting about 100 times more than the limit. Not so much for the manganese. One of the reasons was that when the Dongjiang conveyance system was built in the early days, it was in the form of an open channel. Okay, so water is being pumped in the channel, pass through another lifting station, going up and so on. Through that 60 kilometer of channels, the settlement increased in the 70s through the 80s. So the settlement take the water from the channel, and in return, they give you some wastewater back. So that was the reason for the pollution in the Dongjiang water. So that was a major issue in Hong Kong in the 90s, and subsequently there was a discussion with the Guangdong government, and they have constructed a designated aqueduct. What it means is it bypasses all the settlement along the old channel. So the water that we are getting after 2003 is pretty good. So LT said that they've got a security of water quantity in the next 20 years. And if there's no further deterioration in the water source, we're actually getting quite good water as well. So today, that's the kind of water we're going to deal with, but we cannot ignore completely what has happened in the past. So that's the framework of what we're going to do next. Okay, in Hong Kong, most of the treatment plants are still using the conventional technology. It is as good as it is. A lot of places in the world, except that the conventional technology cannot deal with CNG directly. Okay, so I'll just go through the technology first. You can see that in our water we use filtration most of the time. Filters cannot take out soluble substance. So when it's dissolved in water, you cannot take it out. So what do? So we add in chemicals in to precipitate it, so take it out of the soluble form so that we can remove it from water. All right, we have some particles, okay, insoluble. So we try to make it bigger, let it settle out more quickly. Okay, so and then the final particles are removed by filtration, and then add chlorine to it. This is a typical process diagram going through the process. And you can see that this is the raw water, this is the water with the chemicals in, and after all setting out, this is what we got, clear water. Okay. This is a layout on the design of the clarifiers, settling of the solids. After going through this clarification, we then go through the filtration. In the water tap, we remove the tap throw it away every 3 months. For water treatment work, we can't do it, so we have to clean it. Okay, this is how we clean it. Use air to blow it up, and then use water to drain it. Okay. We then talk about the utilization, land utilization. Okay, you can see that this is a slow process and taking up a lot of space as well. And this is view of Shatin. You can see that the clarifier takes up about half of the area of the site. So can you do anything better? Yes, there are a number of proprietary technologies available. You can reduce the size of the clarification by 10 times, but there's no free lunch in the world. Okay, you have to pay more in terms of the equipment as well as the long-term O&M costs. Okay, and for the CNG treatment, basically either you use membrane or you add in an additional disinfection in the future, okay, to kill all these parasites. So how's the water like? Based on the WHO standard plus the US EPA standard, actually our water fully complies with those standards. Talk about what do we have next. I mean, all the speakers talk about the potential blockage in the water. So what we have to do is to conserve water and then look at different sources in future. So primarily, LT talked about the education measures already, so I'm not going to repeat it. Desalination is a new topic. All right? A lot of places are using desalination at the moment. Basically, two processes. The thermal process, which we have done, used in 70s, but it's very inefficient. New technologies are more efficient, but it's still very expensive. So the topic that we talk most today is membrane. Membrane is really a very fine paper with very fine holes, okay, that blocks everything. Okay, this gives you an idea of the various pore sizes, the membrane, reverse osmosis somewhere here, sand filtration somewhere here, and the final pore membranes in this region. Okay. So essentially, it takes out every minor particles in water, but there's a lot of maintenance issue with it because it's so small that if it's being blinded, blocked, it will fail. Okay. So this is a typical diagram of the two processes: the bigger hole membrane and very fine hole membrane. And LT mentioned about the pilot test that the WC have done. Basically, the two locations have different characteristics. Another water resources is the use of the effluent produced from the treatment works. Again, Hong Kong has tried certain technology, which is different from what's being used overseas. But the reuse of effluent, the major issue is the public acceptance. Okay, people don't like drinking dirty water, basically. Again, those are the pilot trials carried in Hong Kong. The reused water is mainly used in irrigation, toilet flushing, and water features. Okay, not directly drinking. Okay, it's a bit rushed, but technology has an important role to play. Okay, but high technology can save space. Okay, get the safer water, but it's more expensive. Let's look at some figures to put into perspective. In a conventional treatment work like Sharting, it's just looking at the operation aspect. You can see there's only chemical and a few mixers. Okay, so it's pretty low. If you're going for desalination, you need a lot of energy in pumping, as well as chemical and replacement costs. And for the reuse, because of small quantity used, the replacement cost of the membrane tend to upset the figure. So don't take these numbers as absolute numbers because there are different checking, different calculations, different assumptions and so on. But that gives you the order of magnitude on the cross difference between the different technology. Okay, I think everybody is using the same picture. So we don't want to see this again. And so conserve now. Thank you.